Welcome everyone. Welcome to the machine learning session. In this session, we are going to discuss about classification tree technique. Before I get into the classification tree technique algorithm, I will be walking you through a case study. I'm taking the case study from banking domain. As you can see, the title heading, Retail Banking Case Study. So let's just get started with the classification tree. Classification tree falls under the supervised machine learning technique. The moment I say it is a supervised machine learning technique, it would be obvious to you that while building a classification tree, we will have the output, that is the target column, available at the time of analysis. The output can have two or more classes. Now, what do I mean by output? Let's take a simple example. You have given loans to many customers. You have given personal loans to many customers. Now, the output of the loan is whether the customer defaults or whether the customer pays the EMI regularly. So you have two possible output: customer default, customer does not default. Another example, you have got lots of employees in your organization. In the upcoming month, some employees will tender their resignation and many others will not tender the resignation. Output in this case is resign or not resign. These are examples where the output is binary, or I can say dichotomous, because there are two possible outcomes: resign, not resign, default, not default. In other words, you can say yes or no, true or false. However, it is not necessary that the output be restricted to only two classes. You can have two or more classes. For example, you attend a training program, and after the training, you have been given a feedback form. In that feedback form, you have to rate the trainer, and the rating is given as average, poor, good, excellent. So you have now four classes. So the point is, the output need not always be two classes. However, majority of times in business decision making, and the moment you talk about decision making, decision of yes or no, there are many such problem statements where the output falls in a binary category, dichotomous category, where you have only two classes: yes, no, whether the machine is going to break down, yes or no, whether the employee is going to attrite, yes or no, whether a person to whom loan is given will default or not default. You make a marketing offer to a customer, whether the customer will buy the product or not buy the product, yes, no, buy, not buy. So there are many such problem statements where you have to predict the class to which a particular record, a particular object, a particular customer may belong. And this kind of a problem statement is a classification problem. And it falls under the head supervised machine learning, because when you are going to build the model, along with your input parameters, you will have the output class available for your learning purpose. And one of the technique is a classification technique. Besides classification, there are many techniques. There are almost 10-12 techniques by which you can solve a binary output, dichotomous output problem statement. One of the reasons why classification technique is the most used, and that is the benefit or the pro of this technique, is the technique is easy and simple to understand. Let me increase the screen font size. Okay. Yeah. So I was talking about the pros of this technique. The pros of this technique is it is simple and easy to understand. Okay. The output is in a graphical format in the form of a hierarchical tree, thereby making interpretation very easy. Now, this very positive aspect, the output is in the form of a hierarchical tree, thereby making interpretation very easy, sometimes becomes the con of this technique also when the hierarchy tree is very long. When the hierarchy tree is very long, showing the entire hierarchy tree on a flat computer screen may sometimes become difficult, and in that case, it becomes difficult to read. Okay, sometimes this also becomes the con. The same positive becomes the con. Now I'm going to walk you through a case study where we can use a classification technique. The preamble to this case study is there are many banks in India, and if you go to any bank, the largest portfolio, the biggest portfolio of any bank is a savings account portfolio. The reason is very obvious. All of us, as a banking customer, we require a savings, a deposit account. However, it is not necessary that all of us need a loan. If we don't require a loan, the loan account will not be there. As such, the biggest customer base you can understand is the savings account customer base. Now, many of these savings account customers typically have a relationship with more than one bank. The reason why customers end up having multiple bank accounts with multiple banks is currently I am working, say, with a particular technology company, and 6 months down the line I switch my job. The next company may have a payroll relationship with some other bank. They will ask me to open a new bank account. Or I move from one location to another. In that case, I would like to open another bank account with a bank which is closer to my new residence. Though most of us nowadays very rarely visit a branch, however, still we would like to have the bank account with a branch which is close to our residence or our office. In case of emergency, we can go to the branch. That's the benefit. Sometimes we change our banking relation just because certain services have not been delivered properly by the customer relationship manager, and as such, we switch our account. There are many such reasons for which we have multiple bank accounts. So it has been observed that many of the customers have multiple bank accounts, and because of this multiplicity of accounts, some account of the multiple accounts, one of the account becomes your primary account. Basically, that account you do most of the transactions. Your money comes in, your money goes out. The other accounts you use very rarely, or quite often you even forget to use for years and months and years. That account becomes your secondary account. The account where you do most of your transaction, I repeat, is your primary. The account where you do very few transaction or you forget doing any transaction becomes your secondary. It has been observed that 40% are dormant. What is dormant? Dormant is an account having no transaction for last 6 months. If you do not do any transaction in your savings account, bank may classify you as a dormant, which means you are not active. The banks would not like to have dormant accounts. Bank would like to have active accounts, because if the account is active, money will come in, money will go out. You will use debit card at POS terminals. Bank will make interchange income. Because you put your money in the bank account, in your savings account, bank can use that money to give loans to the borrowers. So as such, it is very clear bank would like to have active accounts. However, the dilemma of many banks is 40% of their savings account is dormant. So if you are managing such a portfolio, obviously you will have one of your objective as, can I win back the dormant accounts? So here we are going to discuss dormant account win back case study. I've explained you banks have the largest portfolio, which is savings account. Customers transact frequently in certain accounts, those are primary accounts. Same customer may have multiple accounts, one account with XYZ bank and second account with ABC bank. In XYZ bank, customer transacts actively. In ABC, customer has not transacted for 6, 9, 10, 12 months. In that case, the account of customer with ABC is a dormant account. ABC bank would like to activate you, win back you, and for winning back, the ABC bank may have to do something. So the business challenge is, the challenge for bank is to activate their dormant account, that is win back them. However, a huge base is inactive. Almost 40% of accounts any bank has is inactive. Now I am discussing a case study where a bank has an overall customer base of 40 crore accounts. Now, if a bank has an overall customer base of 40 crore savings account and 40% of them is inactive, which means the total base of the bank, which is inactive, dormant, is 16 crore. It is a huge base. It will not be possible for the bank to do campaign to each and every dormant customer, because if you do a campaign to all the dormant customers, you will spend a huge amount. Even if you assume the cost of campaigning per customer is 20 rupees, targeting 16 crore dormant accounts would mean spending 320 crore rupees. So it is a huge cost. How do we manage these kind of business problem statement more intelligently, such that we are very confident about the profitability of these campaigns? Now, in these kind of scenarios, typically what you may have to do, you may have to run pilot campaigns. In a pilot campaign, you do not go all out targeting everyone. You take a small sample you run a campaign on a small sample so that you can derive the learnings. And based on the learnings, you then start building a campaign on a larger base. So the bank whose case study we are discussing, we are not deciding, the case study which we are discussing, the bank decided to execute a pilot campaign. In the pilot campaign, bank randomly took 100,000, that is 1 lakh dormant customers, and they connected them through multiple touch points like email, SMS, direct mailer, IVR, phone banking, calls, RMs, talking to them, etc. So they took a multi-pronged approach where through multiple channels they tried to reach out to the customer to communicate their offer where benefits are given to customer if they start transacting with the bank. That is, if they activate. Now, this entire campaign, when you're sending out communication, it entails cost. The information given is the cost of sending the campaign, which means I doing a communication, a SMS being sent to you, probably 1 paise, a email being sent to you, probably 1 paise, but a direct mail courier sent to you, probably 15 rupees, 20 rupees. A IVR call, 1 rupees. So this way it was found out the cost of reaching out to customer per person will turn out to be rupees 25. Now, if customer comes back and say, hey, I want to activate, there will be some fulfillment process. Customer says, I would like to activate. So customer may want certain passwords which he or she has forgotten, reach to him by courier. If the account was dormant for a longer time, the bank may have to do KYC once again. So there may be many reasons where the dormant activation may require certain fulfillment steps. And the cost of fulfillment is rupees 350. The fulfillment may involve the customer saying, I'll activate only if you give me a debit card free of cost. Now, issuing a plastic free of cost itself is a cost. It may cost 100 rupees, 125 rupees, but it is a cost. That is cost of fulfillment. So average cost of fulfillment was identified as rupees 350. These are certain details which are available to you. Now, in this entire thing, what was the offer sent? Because if I'm dormant, you want to activate me, you have to give some offer to me. The offer was the customer has to deposit a sum of rupees 25,000, and on an ongoing basis, the customer has to maintain an average balance of rupees 25,000. If the customer activates and ensures that he or she is going to maintain an average balance of rupees 25,000, in that case, if the customer asks for a fresh debit card or customer has got some charges for not maintaining the balance in past, those will be waived off. Any password customer has forgotten, after fulfilling the necessary processes, the bank will issue a new password free of cost. So there are many offers given to the customer to reactivate them. So in the given scenario, it was observed in the pilot campaign where 1 lakh customers were targeted, 10 percentage, that is 10,000 customers responded to the offer. 10% of the 1 lakh customers whom offer was given responded. They activated. They said, okay, we want to restart the relationship we will on an ongoing basis maintain 25,000 rupees average monthly balance in the account. So if you see this entire thing, if you see this entire data, the way you can visualize the data is, this is your 1 lakh base whom you send the offer. Of this 1 lakh, 10,000 after the campaign they activated, so 10k, and the remaining 90k did not activate. So here you got 90k. So these two segments, I can say this is win back and this is no win back. No win back. Again, I have got two classes. Win back, no win back. I have all the historical data of these 1 lakh customers to whom campaign was sent. This becomes my input. The output of the campaign, win back, no win back, which customer activated, which customer did not, is also available with me. So this becomes a supervised learning problem. And for supervised learning problem, where you have got 2 or more classes as your output, we can use a classification tree. The classification technique was applied, and the output of the classification tree is as shown in the diagram here. So this is an application of classification tree technique. We'll now explore and understand this classification tree output in detail. Let me blow this image in a new tab. Okay. So here I've got this image in a bigger screen. Okay. So let us try to understand this output. At the top, we have the entire data, and we call this as a root node. The term given is root node. This is the starting point. So in this, you can see there is a mention of dormant 100,000. What percentage of customers were win back? 10%, and in absolute terms 10,000. So what happens is, this entire data of 10,000 customers with a column having the information win back or no win back would have been passed as an input to a classification tree algorithm. Let me try to explain this data structure in an Excel format. So the customers to whom you would have campaigned, you would have some information like customer ID, age, gender, length of relationship, last transaction date, current balance in account. You can just imagine that you can have many variables about the customers. These variables can come from the time period when the customer was active. You can have variables like number of credit transactions in the month, in active, last active month. At that point of time, when the customer was active, you may have information total cash inflow, total cash outflow, that is debits. You may have many such variables. These all become your input variable. At the time of campaign, you have these variables only. When you have executed the campaign, you have sent them a message, an email. After messaging, the customer responds. And after the customer has responded, some customer respond and some customer don't. So you have this response, or I will say response slash conversion. Conversion means the customer took the offer. So yes, 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 no, 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 no. Here you have these customer IDs. So this becomes your entire data. This is how your data would look like. And this data you will pass to the classification tree algorithm, where you will say, okay, this is my output column and these are my input columns. Can you now find some relation between this output with respect to input? So you will have to pass this to an algorithm. We are not getting into that, how that algorithm works. This algorithm will now analyze the data. After analyzing, the algorithm will find which of these input variable is a strong predictor. Which of these input variable is a strong predictor? When I say strong predictor, a variable which will be able to better separate out the convert customers from the non-convert customers. The variable which is able to better separate out the responders from the non-responders, in this case, would be the strongest variable. So the algorithm will automatically do the analysis and you may get some output, like in form of a hierarchical tree, which is shown here. And if you now analyze this hierarchical tree, it tells you, if you want to activate dormant customers, the first and foremost variable that you should see is what is the inactivity period. Customers who are inactive for 6 to 9, 9 to 12, greater than 12 months. The customers which are inactive for more than 12 months, the win back possibility is only 2.6%. Whereas customers who are inactive for recent 6 to 9 months only, win back possibility is 15, whereas in 9 to 12, it is 12. So what you can see is my overall win back success was 10%, but just by segmenting, by breaking the entire data based on length of inactivity, I find that certain customers who are recently gone inactive, it is easy to activate them and the success rate is higher. Whereas those who have been inactive for 1 year, 2 year, probably those customers who are already lost, now trying to activate them is very difficult. Still, there is a margin of hope and only 2.6% can be activated. The data is then further broken down. Now, each node that you get can be further broken down. As you can see, this data is further split, whereas this data is not further split. Now, why certain node is further split and why certain node is not split further? Again, there are rules which are defined in the classification tree algorithm. Can we customize those rules? Yes, we can customize those rules. We will see all of that when we build a classification tree algorithm using Python. However, for now, you just go with the flows, assuming that, okay, the algorithm can take care of this also. When algorithm can find out which variable among many variable is important, algorithm can automatically decide based on that variable inactive how it should break the cutoff points. The algorithm can automatically find. The algorithm can now, the node which was created from root node, you got these child nodes. These child nodes can be further broken down, and which variable to use further, again the variable will decide. Again these nodes are further broken down, and which variable is to be used. So you can see there is some recursive process. There is a starting root node. You have to identify which is a variable by which I can get a better separation between the response class vis-a-vis the non-response class. You get certain child nodes. Each child node is further evaluated to see can we further break down. So this process iteratively, recursively goes on till a point is reached where you see certain nodes are now not further broken down, where the algorithm now feels there is no point further splitting those nodes. The nodes which are terminal, which are not further split, are called as terminal nodes or the leaf node. The nodes which are split further, which are gray shaded here in the picture, those are called as internal nodes. And the starting node we have already seen is called as the root node. So here what we are trying to understand is, in a classification tree algorithm, when you have input and output, the objective is to separate the classes of the output column, the records of converted customers versus records of non-converted customers. But how do we separate out? Which variable will be able to better predict them? You cannot say, okay, hey, I have to separate out the converts and non-converts. So I'll take this entire data. Let's say here there is Y. I'll take the entire data and do a data sort. Data sort J column, response, non-response. This is the heading column which should come up. Okay. But I cannot do a sorting based on the column and say, okay, I have separated. The point is not doing sorting. The point is finding out relation between input column vis-a-vis the output column, because subsequently when you are going to use this model, the classification tree model, subsequently when you are going to use, at the time of application you will not have this column. At the time of application you will have only this, and then using the model you have to predict which customer is more likely to be a convert and which is less likely to be a convert. And those who are more likely to convert, you will target them. So you require a model, you require an output which is something like this, which gives you rules. And now how are the rules? The rules are something like this. Now if you just focus here on this particular node, what this rule is saying, I'm just putting a double tick. What is the rule saying? If a customer is inactive for more than 12 months, the chance of win back is only 2.6%. Overall average was 10.6. Your chances of converting a customer who is inactive for more than 12 months is just 2.6. If the cost of targeting this segment is much higher than the revenue by which you are going to get by this conversion of 2.6%, if the revenue is too low compared to the cost of reaching out and targeting these 34,000 customers, there's no point campaigning. So you are getting rules, then you can apply your ROI calculations. What is the cost of targeting? What is the revenue I can expect? Revenue minus cost is profit. At each terminal node, you can now start doing profitability calculations, and based on the profitability calculations, you can decide which terminal node to target and which terminal node you should not target. And once you have decided the terminal nodes which you would like to target, you can find out the rules. And what is the rules? The rule is, assume I want to target this terminal node. I need to simply traverse back the path. So this is the path of reaching to this terminal node. So what it means is, if I have to target customers having this kind of a profile, I need to see how long the customer is inactive. If the customer, I'm saying now applying the model. After having built the model based on pilot campaign, subsequently you will apply the model. So the model is now saying if the customer is 6 to 9 months and there are certain charges on this customer, lean charges, but the charges is 1000 to 5000, and the customer is gender male, and the customer used to do 10 transactions when the customer was active. I'm just reading the conditions which is given here. If these conditions are met and you target such customers, you are likely to get 27.4% conversion. You are going to get 27.4% conversion. So this is how the classification tree rules are given. All these rules are captured in the classification tree model. So we apply these kind of classification techniques. After applying these classification techniques, we have to see how these classification techniques helps increase the profitability of the campaign and build how these campaigns can be made more profitable using the classification tree model. Terminologies I have already explained in reading the tree. There are three important terminologies: root node, the starting point of the tree where all records are present; terminal nodes, the node which are not split further, they are called terminal or the leaf node; the child nodes which are further split, but that is they are not terminal, are called as internal nodes. These are some classification tree terminologies. Let us now see the interpretation of the entire output. The win back rate at the root node is 10%. It simply means that if I continue running campaigns without applying the classification model, I randomly pick up the inactive customers from my base without seeing who is inactive for 6 months and who is inactive for 10 months or who is inactive for more than 12 months. I just randomly pick up the inactive base and target and run a campaign. I will expect win back of 10%. If I simply apply one filter, okay, that the length of inactivity is greater than 12 months, I know in that segment 2.6% is the win back rate. I feel that at 2.6% conversion, I may not be profitable. So what I can decide is I will not target them. The moment I just knock off the base where I have got inactivity more than 12 months, what will happen is I will be targeting the remaining segment of the customer. Just Just think of this one simple filter, and what we get is 40,000 and 25740. These many customers will be targeting. So I'm just writing that two numbers, 40,000 and 25740. And what is the number of win back is 6,000 and 3121. 6,000 3121. So total, let's just do addition. This addition, so my success rate in this campaign would become 13%. So by just applying a simple filter of not targeting customers having length of inactivity more than 12 months, I have increased my campaign success rate from 10% to 13.9%. So this kind of interpretation we have to start making from the model. On the other hand, if I target, say, this base, let me highlight it, I will get a win back of 27.4%. Or if I target this base, I will get a win back of 25.6%. Or if I target this base, I'll get a win back of 23.7%. These win back are much higher than overall average of 10%. So what it means is we need to now see how profitable are we by targeting at different segment level. So we need to do certain ROI calculations. A close observation of above terminal nodes reveal that a few nodes have very high win back, which I showcased you above, and those nodes I have marked green. The nodes where we have very low win back are actually marked red in the above diagram. Okay. So let's get into ROI calculation. First, we will do ROI at a root node. The information which has been given to us is cost of campaign per customer is rupees 25. If a customer converts, customer says, okay, I would like to activate given your offer. Some customers will say, hey, I would like to activate, but I have lost my debit card. Kindly reissue a new debit card. Bank will be doing it free because that is the offer. Some customer may say, I've forgotten the password. Kindly regenerate my PIN. So bank will regenerate the PIN and make courier it. Again, it's a cost. Some customers KYC might have become outdated. So re-KYC might have to be done. So there are many things because of which there is a cost of fulfillment, and that is given rupees 350 rupees average per conversion. What is the customer supposed to maintain on an ongoing basis? An average balance of 25,000 rupees. Now, the money which is maintained by a savings account customer in a bank, that money bank uses to give to borrowers. We as savings account customers, we are depositors. Other customers who are in need of money take loan. They are borrowers. To savings account, bank gives interest. From borrowers, bank take interest. There is cost of operations, cost of managing this banking infrastructure. Let us assume there is an interest margin, net interest margin earned by the bank is 2%. So let us do some ROI calculation. What will be my campaigning cost? My campaigning cost, in this case, we are targeting 100,000 customers, that is 1 lakh customers. At the root node, we had at a cost of 25 rupees. So my cost of reaching out is 25 lakh, that is 2.5 million. Cost of fulfillment, there is a 10% success rate. So how many win back will be there? 1 lakh into 10%, that is 10,000. And on average, my cost of fulfillment is 350 bucks. So 10,000 into 350, that is 35 lakh is my cost of fulfillment. So 3.5 million. What is the revenue? I'm not just going to incur cost. I'm going to say some makes money also. The customers who are going to convert, they are going to keep money. That money I'm going to give to borrowers. There is a net interest margin which I'll make, and that is 2%. So 10,000 customers into 25,000, the money kept by them. On that 2% is my net interest margin. This calculation would work out to be 5 lakh. Sorry, 50 lakh. 50 lakh, that is 5 million. This is my revenue. So what will be the profit? The profit or the loss, in this case, we see 5 million is revenue and 6 million is the expense incurred. There is a 1 million loss. So in the first year, if I take only the revenue of first year, I will make a loss. This campaign can be profitable if I consider revenue for 2 years, because this revenue is only for the net interest margin, is only for the first year. I assume the customer will continue for next 5 years. So in second year also I'll make a interest margin income of 5 million. Now second year it will become profitable. However, I want the campaign to be profitable in the first year itself. Now if the campaign has to be profitable in the first year itself, my campaign cost is 6 million and revenue is 5 million. The campaign cannot be profitable unless my win back is higher. Now to be profitable, can we find out what is the success rate? How much conversion I should have so that I'm at least break even? Now for break even, what you require is your revenue should be equal to cost. Cost elements is, this is my campaigning cost and this is win back into fulfillment. The point is how many win backs I require so that the campaign will be profitable. If I do reverse calculation, in the reverse calculation, I find I require 16,667 conversions, but the campaign is giving only 10,000 conversions. Or let us express it in a percentage term. I require 16.67% conversion. However, at a root node, we saw our conversion is only 10%. If the conversion is only 10%, one option is I should stop doing campaign. But the other option is this classification tree is actually giving you, I'll show it again in the big screen, the bigger image. This classification tree is giving you opportunities where it is saying here my conversion is more than 16.67%. Here my conversion is more than 16.67%. Here my conversion is more than 16.67, and here also it is more than 16.67. So if you start targeting only these terminal nodes and you forget all the red terminal nodes, your campaign will be a profitable campaign. So what the classification tree technique did? Classification technique helped classify your customers and helped you identify which customers are more likely to convert, which customers are less likely to convert. And because of this classification, a campaign which was not profitable at the root node has become profitable, at least in some of the segments. So rather than losing out the entire opportunity, it is helping me capture some of the opportunity without running into losses by running profitable campaigns. Now let us do the calculations of how profitable our campaigns would be if we just target the green segments. So here now I'm going to show profitability at green segment level. Our strategy from the classification technique will be target only those segments where our winback is more than 16.67. Those nodes we have already marked as green in our diagram above, in our classification tree plot above. If I take the numbers of those green nodes, in the green nodes, the dormant accounts are 11,997 plus 5,400 plus 452 plus 10,596, that is 32,445. So what we are saying is, rather than targeting 1 lakh customers, we should target, rather than targeting 100% of the dormant base, we should target only 32% of the dormant base. This one. Now in this base green nodes, how many winbacks are there? 3076 plus 911 plus 1220 plus 2510, that is 7717. Out of the total 10,000 winback, 77% of the winback is sitting here. What it means is, just by targeting 32% of the overall dormant, I can capture 77.17% of the potential converts. And my win back of this overall campaign will be 7717 divided by 32,445, that is 23.78%. In summary, just by targeting 1/3 of the dormant base, we can capture 3/4 of the potential conversion. We will lose only 1/4 of the opportunity. We will lose only 25% of the opportunity. What is the profitability of the green segment? In green segment, if we would have done campaign only to the green segment, I would be having a revenue, not targeting. I will have a revenue from these 7,717, a net interest margin, which is this 25,000 into 2%. My cost of fulfillment would be 7,717 into 350, and the overall base which I would be targeting is 32,445. For getting this 7,717 conversion, my profit would be this amount, 3,46,425. In this pilot campaign, if from that pilot campaign I'm getting this learning by targeting only green segment. How is this learning useful? As a bank, you do not have dormant accounts only today. 1 month down the line, customers who are active, some of them will become dormant. 2 months down the line, more of the active may become dormant. 1 year down the line, more of the actives who are today active may become dormant tomorrow. When those active become dormant tomorrow, amongst them whom we should target and whom we should not, the classification tree technique is telling us. And the classification technique is saying that target the green nodes, because in the green nodes you are profitable. Okay, how would this apply for a full-fledged rollout? From a pilot campaign, how do we take this to a full-fledged rollout strategy is what we have to discuss now. Going forward, the bank can use this model for pinpointed targeting of dormant accounts. As I mentioned, on an ongoing basis, new customers who are active today may become dormant tomorrow. But is there a need to target all the customers who become dormant? No. The model has clearly suggested there are certain profile of customers who are more likely to convert, and there are certain profiles which are less likely. How do we get the profile? By navigating our path from the root node till the terminal node and seeing what all condition to apply to find out whether a customer is more likely to get active or not. We were talking of a case study where we had 40 crore customer base, and of that 40 crore, assuming 40% is dormant, we said a bank may have 16 crores dormant accounts, that is 160 million. Potentially I can reach out to all of them. However, if I reach out to all of them, I'm going to make a loss. From above analysis, we saw that we should be reaching out to only 32% of the dormant base. What it means is, from this entire base of 160 million, which is dormant in my book today, I should reach out only to 32%, that is 160 million into 32.4, that is 51.84 million customers. From this 51.84 million, I'm expecting a win back of 23.78%, that is around 12.3 million. Now, if these 12.3 million customers are activated, they will maintain a deposit of 25,000. Now, this 12.3 million into 25,000 is close to 30,750 crore, or as expressed in million, I should express it in billion rather than in million. The deposit mobilization would be 307 billion, or if I express it in crore, it is 30,750 crore of deposit mobilization in the savings account. Now, if a bank gets this 30,750 crore, they can make use of this money for giving loans, and based on the loan, they make a net interest margin of 2%. So I'll have a 30,750 crore or 307 billion into 2% as my revenue. But to get this revenue, I have to run a campaign on this 51.84 million base at a cost of 25 rupees, and from this 51 million base, I'll have a 12.3 million conversions and a cost of fulfillment 350. So I have to subtract these costs also. So if I subtract that, the bank can make a profit of 549 million, that is roughly 55 crore, 54.9 crores. Deposit mobilization in a banking domain is a very important and a crucial part of business strategy, because if you have deposits, you will be able to lend. If you do not have sufficient deposits, you will not be able to lend to the borrowers. As such, many banks time and again run deposit mobilization campaigns. Now, when they run these deposit mobilization campaigns, if they randomly target their inactive customers, they may incur more cost than the profit that they will be making, than the revenue that they will be making. As such, it is very important to identify whom you should reach out, where you are more likely to convert the customer and get the customer activated again. The second important point is, getting a new customer in the system is always more expensive as against retaining an existing customer. From all of these standpoints, deposit mobilization, win back campaigns is an important part of bank campaign strategy. Dormant account win back campaign, it is a very low hanging fruit by which banks can quickly mobilize deposits, grow their savings account portfolio, and it will also help them weed out inactive accounts. If you know that these customers are not likely to activate, you should take a formal decision that we are going to probably send a one email notice or one courier intimation saying that you have been inactive in our portfolio for long, the balance is also not sufficient. As such, we request you to go ahead, close the account, weeding out the inactive. There's no point doing IT backup, database backup of these inactive accounts on a continuous basis. It adds to cost. And as the number of customers, really active customers, which is there with you, the relationship manager who is managing those relationships will be able to better handle them. As such, they will be able to better build the loyalty with the customers. These are benefits of dormant account win back campaign. And with this campaign, I have tried to explain you a practical application of a classification tree technique. In the upcoming session, we are going to discuss the classification tree algorithm, how the classification tree algorithm is applied in such classification problems, what are the different types of classification tree algorithms. All of this will be discussed in our upcoming session. Till then, thank you. Bye. See you in the next session.